Hi everyone, this lesson is for Algebra 2 honor students. This is Quadratics, Chapter 5, Day 3. I want to share this photo with you. We took it in Northern Ireland, and this is Dark Hedges, so if you've ever been there, it's actually pretty cool and creepy. Okay, we are getting started. We have a warm-up. Our warm-up says to find the vertex, the axis of symmetry, and the x and y-intercepts. So let's get started with that. The first thing we are going to find is the y-intercept. So we're going to set x equal to 0. And in doing that, those cancel, and we get 0, comma, negative 6. So 1, 2, 3, 4, 5, 6. So down here at 0, negative 6. Next, we are going to find the x-intercepts, and we find the x-intercepts by setting y equal to 0. So in setting y equal to 0, we would go 0 equals x squared minus x minus 6. And for this problem, I would suggest factoring to just start with, because we haven't really done the quadratic formula too many times yet. Factoring, we're going to have x times x. To make negative 6, it'll be a negative 3 and a positive 2, because those multiply to be negative 6 and add up to be negative 1. We split these up. We set both sides equal to 0. X minus 3 equals 0, so x equals 3. And then you have x plus 2 equals 0, so x equals negative 2. So those are my x-intercepts here at negative 2 and at 1, 2, 3 right here. And so far, so good. Now we're going to find our vertex, and we're going to use the completing the square to find the vertex. So we're going to move this negative 6 to the right. We're going to get y plus 6 is equal to x squared minus x. We're going to complete the square. Just keep in mind that when you do complete the square, your x squared term, your coefficient in the front, your a term, that value has to be positive and it needs to be 1. And if it's not, then you're going to factor whatever that is out so that it is 1, positive 1. We're going to take half of this term. So we're going to take negative 1, we're going to take half of that, and then we're going to square that. And negative 1/2 and negative 1/2 is 1/4. And so we're going to add 1/4 to both sides of the equation. And on the left, I get y plus 6 and 1/4, which is 25/4. And on the right, I'm going to get x minus, you take the square root of x squared is x, square root of 1/4 is 1/2. And that's basically how you get those values. And then if there's one minus sign, that's minus times minus, negative times negative, positive. So you have to have a negative sign here. One more step to put this in vertex form. So it's going to be y equals x minus 1/2 quantity squared, and then subtract 25/4. And this is what we call vertex form because it gives us the vertex. And our vertex is going to be opposite. So 1/2, comma, negative 25/4. So that'll be over 1/2 and down 6 1/4, so about right there. And so there's our vertex, and we're going to put 1/2, comma, I'm going to put 1/2, comma, negative 25/4. And for that right there, let's see, we're going to just graph it. Looks something like this, okay? And just a note, you also can find the axis of symmetry here, and that's just dropping this down like that. And that value, the axis of symmetry, if you remember, that's equal to negative b over 2a. So that's this value, the x coordinate. So my axis of symmetry is x equals 1/2, okay? And that's a line. So you do need to write that as a line, like an equation, right? And then the only other thing here that I might ask on the test for sure is this point right here, which is the symmetric point, which is you take the x coordinate, you double that, so 1/2 and 1/2, that's 1, comma, and then you drop down or up, depending on your y-intercept, if it's up or down, and this would be negative 6. And so that's it. Axis of symmetry, check, x and y-intercepts, find the vertex. Okay, right on. So our learning targets today are, we are going to be using the quadratic formula to solve an equation. And when we solve an equation, the results are always to find the x-intercepts. That's what I'm asking you to do. When I ask you to solve a quadratic equation, I'm asking you to find the x-intercepts. Another name for that of solve is x-intercepts might be to find the roots or find the solutions. Okay, all of these are equally congruent words, all the same words basically saying to do the same thing. The other thing, and that's basically to solve and find the x-intercepts, or where my graph is crossing the x-axis. I'm also going to be using the discriminant, which is b squared minus 4ac. And to use the discriminant, what I'm doing with that is that's going to tell me whether or not my graph is imaginary or real or imaginary. Because a discriminant basically is saying what's underneath the root, which is your b squared minus 4ac, and whatever's underneath that root, it could be positive or negative. And if it's positive, it's real x-intercepts. If it's negative, they're imaginary. And lastly, we're going to revisit the vertex shortcut to find the vertex of the parabola. So let's move on. So again, different ways to solve a quadratic, and that's the big word, solve. I mean, it doesn't seem like it's a huge word. It's very important, but solve means find the x-intercepts. So translation, if you have a quadratic and the directions say solve, you are looking for the x-intercepts, period. That's it. And those could be called roots, they could be called solutions, but they are the x-intercepts. It's where the graph crosses the x-axis. And there's multiple ways to find that, okay? One way is factoring, as you saw in the last problem. We did that. One way is to use the quadratic formula. We're going to do that. You guys like my square root here? Anyway, using square roots, also completing the squares. So this is like a combination of stuff. And I'm going to go back to the first problem because I want to show you, while completing the square and using and squaring both sides, square roots, isn't the most popular method, it is sometimes the most convenient. And so let's go back for a second. And right here, if I came back here, and I'm going to erase this part right here just so that you can see I have a little bit of room. What I'm looking for are my x-intercepts, these right here. And I'm looking for those values a different way. Yes, I found them already by factoring. No, it's not the only way to do that. So let's revisit this. Remember, if I want to solve the equation and I want to find the x-intercepts, I do need to set y equal to 0. So that's going to go away. So that means, see this 25 force, I'm going to move it back over to the other side because that's now 0. So we have 25, positive 25 force is equal to x minus 1/2. So quantity squared. And because I've already completed the square so that I could find the vertex, I'm already here. I'm already done. So meaning all I have to do is square root both sides. And remember that when I'm looking for the x-intercepts, I'm looking for two values because it's quadratic. When I take the square root of this, I'm going to get x minus 1/2. That's pretty simple. When I take the square root of the other side, I actually get plus or minus 5/2. And what that means is this. Let me use a different color. I'm going to isolate the x. So I'm going to move the negative 1/2 over. I'm going to get x is equal to 1/2 plus or minus 5/2. And so that's 1/2 plus 5/2, which is 6/2, which is 3. I'm going to get 1/2 minus 5/2, which is negative 4/2, which is negative 2. So if you can see negative 2 and 3, and you write it like this, x equals solution set, negative 2, comma 3. Those are my x-intercepts, check. And so you can see that, hey, factoring might be an issue, especially if it's, something that is giving you a little bit of trouble, but you can square root both sides once you set y equal to 0 if you want to find the x-intercepts. And that's what that does, is it gives me the x-intercepts. All right. Right on. Good. Okay. So we're going to get started with some of these problems. This one I'm just going to solve by factoring. Again, if it says solve the quadratic equation by factoring, I need to set y equal to 0 because I'm actually looking for the x-intercepts. So I know my vertex, not my vertex, my y-intercept is at negative 10, but this is just asking me to solve. So we're going to set y equal to 0, and I'm going to try to factor this, and we're going to get x here times x is x squared. Negative 10, my options are 1 times negative 10, 2 times 5, or one's positive, one's negative, etc. Which one is going to give me the positive 3? Well, that's going to give me if I have a positive 5 and a minus 2. Split that up. we've got x plus 5 is equal to 0, so x equals negative 5. X minus 2 equals 0, so x equals 2. So that means that here and at negative 5, our values, and it kind of looks like this is a little bit on the left side, so I'm going to assume that because it's a positive equation, I'm going to assume my vertex has to be below my y-intercept. So it's around here. We're not sure. We don't care right now because they didn't ask that. They just said to solve the equation. By solving the equation, I found my x-intercepts. That was the job. So we're going to solve again, and we're going to use the quadratic formula. This is pronounced x equals the opposite of b plus or minus the square root of the quantity b squared minus 4ac all divided by 2a. I know in school I learned this. I don't... A negative boy couldn't decide if he wanted to go to a radical party. Being square, he missed out on meeting 4 awesome chicks. The party was all over by 2 a.m. Does that help? I don't know. Try to help remember. I know some people taught songs. I never did that. Quadratic formula to solve the quadratic equation. We're going to do that. So I'm just going to say this. It needs to be in this form. Y equals ax squared plus bx plus c. Label your values. That's just by far the easiest way to start, is to say identify A. A is 2. B is negative 3. And C equals negative 5. So plot your point. Plug your points into the quadratic formula, which again is x equals the opposite of b, which is 3 plus or minus the square root of b squared 9 minus 4 times a times c, which is negative 5. And that's all over 2a, 2 times 2. So we've got, let's see, 4 times 2 is 8. 8 times 5 is 40. Negative, negative is negative, positive. So that's positive 40 plus 9 is 49. Square root of 49, 7. So we have 3 plus or minus 7 over 4. And these are my x-intercepts. You always have to split this up, by the way. You have 3 plus 7 over 4, and you have 3 minus 7 over 4. 3 plus 7 is 10. 10 divided by 4, 2 divides into both, so we get 5 halves, one of my x-intercepts. 3 minus 7 is negative 4 divided by 4 is negative 1. So we've got a negative 1, check, and we've got a 2.5, 1, 2.5. I know I have a y-intercept of negative 5. So basically this is telling me that my graph, because it is positive, because the x squared term is positive, is my vertex then has to be below my y-intercept, could be a lot farther below. We don't care necessarily as far as where it is, because they didn't ask that. They just said solve the quadratic equation. And when it says solve the quadratic equation, then I'm asking you to find the x-intercepts. Set y equal to 0. You'll notice there's no y here. Y is gone. And then find. So for this problem, I am going to complete the square to solve the quadratic equation. So by completing the square, I'm going to move this 6 over to the other side. So we have y minus 6 equals x squared plus 8x. And so we're going to complete the square. Half of 8, so we're going to take 8, we're going to divide that by 2. Half of 8 squared, so that's 4 squared is 16. I'm going to add 16 to both sides. And now I have y plus 10 equals the quantity x plus 4, quantity squared. Now, normally, this would be the time when I'd take that 10 and move it to the other side to put it in vertex form. However, what I'm looking for is to solve the quadratic. That means that I'm looking for the x-intercepts. And if I'm looking for the x-intercepts, that means I need to set y equal to 0. So therefore, this value, no time like the present, goes to 0. And so now what we have is 0 plus 10, which is 10. So we have 10 equals x plus 4 quantity squared. Now, I want to solve for x, and in order to find x, I need to lose the quantity squared. So the way you lose the square is you square root it. So we're going to square root both sides. Now, in doing that right here, remember, if it's an equation, that this square root on the left is going to become plus or minus the square root of 10. On the right, this is going to just become x plus 4. And so now what I have to solve for x is I just move that 4 over to the other side, and I get negative 4 plus or minus the square root of 10. Now, I know that you're looking at that and you're thinking, how am I supposed to graph that? Where are my intersection points? What is that value? So what you need to understand is this right here is completely fine. You can put it into your calculator, and you also can say, well, what's negative 4 plus or minus the square root of 10? So we're going to use the calculator. I have that brought up already. And in using the calculator, I put in the equation x squared plus 8x plus 6. And I found the left value, which was negative 7. So negative 7.16 comma 0. That's one of my zeros. Again, if you have this calculator, and we went over this in a different video, how to find the other point of intersection, you're going to go to menu, and you're going to go down to where it says analyze graph. But instead of finding the maximum or minimum, which would give us verify our vertex, remember, we're going to find our zeros. And so for me, I'm going to go 0 here. And what I need to do, let's see, no 0 found. I need to move this. Let me try that again. What I want to do, I found this 0. Let's see. Hopefully this will work. Find the 0, and we're going to move this over here. And let's see, over to this value, and that gives me my 0. It's sort of like a bound, left bound, right bound. And so the other 0 is at negative 0.838, comma 0. Okay, so let me just verify this with a calculation, because on our calculator, or on our equation, we got negative 4 plus or minus the square root of 10. So let's do that. So let's see, negative 4. Okay, oops. I need to calculate, and I need to come up with a new, there we go, add calculator. So I'm going to go 4 plus the square root of 10. So plus, let's see, control, this value is my square root, 10 over. Now, funny thing about this calculator, if you just hit enter, you get the exact same thing you type in. But you could also hit control enter, is going to give you an approximation value. And so that value is 7.16. And so that's one of my values. And then the other value would be 4 minus that value. So 4 minus the square root of 10. And I would go control enter, and that's going to give me my 0.83. Okay, so those are going to be my x-intercepts. The next value, and oh, by the way, I think for this problem, see this negative 4, that makes a difference, right? So when you put those values in your calculator, see, I didn't put a negative 4 in, so I still get the same, those are my values, but negative 4, okay, negative, nope, delete. Don't want that. Okay, I'm going to go escape. Okay, negative. So negative 4 minus the square root of 10. So control square root 10 over, and approximate that is, there's my negative 7. Okay, that's what I was trying to say. All right, so next type of problem that you are going to see is something like this, where it's find the vertex. And find the vertex, we already found the vertex using completing the square, but let's check that finding the vertex by the shortcut method. Okay, this is what they want us to do right here. So if our equation is y equals 3x squared plus x minus 2, the shortcut method for the vertex is simply negative b over 2a. So again, a is equal to 3, b is equal to 1, and c is equal to negative 2. So negative b, so the opposite of b, so b is 1. So the opposite of 1 over 2 comma a is 3. So I've got negative 1/6. So far, my x-coordinate for my vertex is negative 1/6. Now, in doing that right there, what I would do then is I would plug that value into my equation, which is right here. Now, definitely I would use my calculator, but If you don't have a calculator, I'm going to show you how to do that. You're just going to go 3 times negative 1/6 quantity squared plus negative 1/6 and then minus 2, which becomes 3 times 1 over 6 times 6, which is 36, minus 1/6 minus 2. And so I'm going to simplify this. 3 divides into 36 12 times. So I have 1/12 minus. Now this I would need to multiply by 2 over 2. So that's going to be minus 2 over 12. And this one I would multiply by 12 over 12. And that would be minus 24 over 12. And so what do we have? Negative 1 minus 24 is negative 25 over 12. And so negative 25 over 12. So this would be my vertex if that's what I was looking for this problem for the shortcut method. Now, not sure if that's like the shortest method because we had to work all of this out. I also want to show you how to do this by completing the square. So let's do that just to see what we would get. Is that quicker, not quicker? Completing the square, we would take this 2 first and move that over. So we have y plus 2. And on the right-hand side, we would have 3x squared plus x. Now remember, this value needs to be a 1. So I have to factor that out. So we're going to go 3 times the quantity, x squared plus 1/3 x, right? And because you factor that out. And then now what we have is I need to take half of 1/3. So half of that is 1/6. Square that is 1/36. So I'm going to add 1 over 36 on the right. And on the left, I've got y plus 2 plus. Now remember, it's not 1 over 36 because see this 3? You have to actually multiply that back in. So that's 3 times 1 over 36, which is 1 over 12. So I'm adding 1 over 12. Now, on the right, I'm going to erase some of this stuff because it's getting a little cramped. And so on the right-hand side, I have 3 times the quantity, x plus 1 over 6 quantity squared. And on the left, I've got 2 and 1/12. So 2 and 1/12 is 24, right? 24, 25. So 25 over 12 plus y. So realistically, my vertex is negative 1/2, or sorry, negative 1/6, comma, negative 25/12. And I've found that twice, one time using the vertex shortcut and one time using the actual shortcut and completing the square. Now, I would just say at this point right here, if I was going to, and I think this is a good segue into solving. So I'm going to erase this because I want to just do one more of these graphing ones where I'm solving, and I want to do that right now. So let's do that quickly. We are going to set y equal to 0, and we have 25 over 12 is equal to 3 times x plus 1/6 quantity squared. And so for that right there, let me fix that, plus 1/6. I'm going to square both sides to find my x-intercepts because we already found the vertex twice. You need to lose the 3. So that 3 needs to go away. So we're going to divide both sides by 3. So now I have 25 over 36 is equal to x plus 1/6 quantity squared. Now keep in mind, I'm going to square root both sides now. And when I square root both sides, on the left, I get plus or minus 5 over 6. On the right, I'm going to get x plus 1/6. Move that 1/6 over to the other side, I get negative 1/6 plus or minus 5/6. So that means that my x-intercepts are going to be negative 1/6 plus 5/6, so that's 4/6. 4/6 is 2/3, so I've got one x-intercept at 2/3. And then I've got negative 1/6 minus 5/6, which is negative 6/6, which is negative 1. And there's my x-intercepts. And then along with my y-intercept at negative 2. It's a little bit off. I know my vertex is at negative 1/6, negative 2 and something. So actually, this point here, let me fix this point here, is a little bit off. And so what that means is that my vertex is down here, and it's going to look something like that. Okay, so this actually is a really good question because you can do multiple things different ways. So that's going to set us up for doing what we're going to be doing later on today. Now, the discriminant, though, this is a new thing. The discriminant is what's under the radical for the quadratic formula. It's b squared minus 4ac. Does not have the root, though. But the discriminant is something pretty neat because sometimes the question is just going to be as simple as, when I solve, are my x-intercepts real or imaginary? And how many solutions am I going to have? So for example, when I find this number, b squared minus 4ac, if that value is greater than 0, that means I have 2 real number solutions. Like that last problem, right? Which was 3x squared plus x minus 2. So 3x squared plus x minus 2. B squared, so 1 squared, right? 1 minus 4 times 3 times c, which is negative 2. So 1 plus, what's that? 12 times 2 is 24. So that's 25. So if it's greater than 0, which it is, then I've got 2 real solutions. That means that my graph crosses the x-axis in 2 different places. Check. We already knew that because we graphed it, but that's what happened. If my graph equals 0, that means that my graph, I still have 2 answers, but they are the same value because that means that my graph crossed right there. Meaning, how would I get a 0 value? When you do the quadratic formula, or when you find the discriminant, b squared minus 4ac, basically you're doing this. Remember, if you were using the quadratic formula, it'd be like negative b plus or minus the square root of this value. Well, let's say I ended up with like 49 minus 49. That's 0. That's what I'm talking about. That's what this is saying. And lastly, if I get less than 0, that means that if my discriminant, when I use b squared minus 4ac, whatever's underneath that square root when you're using the quadratic formula, or if you're just doing it this way, if your value is negative, like negative 36, right? Then what that means is that value, that means my answers are imaginary. And if that's the case, then it's floating, right? Okay. All right, so let's try that. So use the discriminant. Just tell me the types of roots. So what we have is b squared. So we know a is 3, we know b is 6, and we know c is 8. So we're going to go b squared, so 36 minus 4 times a times c. Wait, so 12 times 8 is bigger than 36, right? So therefore, my answer is that value is negative. And if that value is negative, that means that I have 2 imaginary roots. That's exactly what it means. For this one, b squared, so 8 squared minus 4ac. So this is a 64 plus some number, 16, right, which is positive. And so this means I have 2 real roots. Okay, that means when I have a real root, it means that my graph is crossing the x-axis in 2 different places. For this kind of problem here, this value here, up here is 8, my y-intercept. It means that my graph doesn't cross because it's imaginary. I still have 2 x-intercepts, but they're not real. They're imaginary. They're on a different plane. They're on a complex conjugate plane, which we already talked about. So just one last problem. We have this. We're going to find the vertex. So move this over. We're going to get y minus 29 is equal to 2 times the quantity x squared plus 8. Half of 8 is 4. 4 squared is 16. But I'm actually adding 32 to both sides. On the right, I get 2 times x plus 4 quantity squared. On the left, I get y 29 plus 3. And putting this in vertex form would be y equals 2 times x plus 4 quantity squared minus 3. My vertex is at negative 4 comma negative 3. So we got negative 4, negative 3. There's your vertex. Your y-intercept is way, way, way up here at 29, which is fine. It looks something like that. My axis of symmetry is going to be x equals negative 4. and that's this graph, that line that cuts right through that. My symmetric point would be -4, comma, which is -8, comma, 29. My discriminant is going to be b squared, b squared, so 16 squared minus 4 times a times c. Let's see, 16 times 16 is 256. And we are subtracting 29 times 8. Use a calculator. 2, 7, 16, 17, 18, 19, 20, 20, 22, 23. This is positive 232, which is 24. So, I mean, that means I have two real intercepts. But, I mean, heads up. Do you see that? I can see that my graph is crossing the x-axis. So I know that my discriminant is positive, and I know that I get two answers. What you have to understand is that your question, let's say on the test, is just going to say, hey, what's the discriminant? So you're going to have to give me that number, and that number would be 24. Okay. Additionally, we found the y-intercept, but we didn't find the x-intercept. And I am going to find the x-intercept using the completing the square method that we started before. So I'm going to take this equation right here and rewrite it, but setting y equal to 0. And so now I have 3 equals 2 times x plus 4 quantity squared. I'm going to square root both sides, but I'm going to move the 2 over here first. You need to get rid of that 2. So we have 3 halves is equal to x plus 4 quantity squared. We're going to square root both sides. And when I do that, on the right, I get x plus 4. But on the left, I get plus or minus the square root of 3 over the square root of 2, which I'm not going to leave like that. I'm going to multiply by root 2 over root 2. And I'm going to get plus or minus the square root of 6 over 2. And then I'm going to move this 4 over to the other side. So this right here, these values, not imaginary, just radical equation, those are my x-intercepts. Because we just solved, but in this case we solved by completing the square and square rooting both sides. So there's a lot of these problems that are on this these slides, but realistically we're not actually going to do all these equations in class. So I'm really glad that you're watching this video. So we're going to do a couple other questions that, heads up, you're going to see at another time. These kind of questions, as well as on the test, that's where they're going to show up too. So your job is to find a quadratic equation that gives you the vertex, but also contains a point. So that means that at -2, 6, there's my vertex, and it contains the point 7, -1. Well, for that to happen, if the vertex is way up here and it has to contain the point, I mean, it can't go up like that. I mean, right? Because then you wouldn't get that point. So realistically, we know that our graph is going to do this. That means that actually, too, that the graph is going to be negative, and so it is going to drop down in that direction. So we're going to start off with our vertex form. And pause. Mom wanted to say hi. Okay, so we are going to start off with the vertex form. So which is y equals hk. So y equals a times x minus h quantity squared, and then plus k. So here's hk, vertex hk. So this value is 6, so plus 6, -2, so that's 2. So we're going to go, this is x plus 2 quantity squared, and we've got a here, and we have this equal to y. So we need a, because x and y can stay, but in order to find a, we need this point. So to find that point, we're going to plug that in. So we're going to go -1 equals a times x, which is 7, plus 2, quantity squared, plus 6. 7 plus 2 is 9. 9 squared is 81. So I have 81a plus 6. I'm going to subtract 6 is equal to -7. So a is equal to -7 over 81, which that value is going to go right here. So my actual equation find the quadratic equation is going to be y equals negative 7 over 81 times the quantity, x plus 2, and quantity squared, add 6. So this would be my quadratic equation for the values that they gave me. We're going to do that again. So we're going to start off with the vertex at y equal, or 4, negative 5. So we're going to go y equals a times x plus h quantity squared plus k. That's minus, by the way. Let me fix that. And in doing that, we're going to plug in our vertex. Okay, plug that in. So we get y is equal to a times x minus 4 quantity squared plus k, so minus 5. And then it contains this point, negative 3, 1, which is x, y. Plug that in. 1 equals a times x, which is negative 3 minus 4 quantity squared minus 5. So this is negative 7. Negative 7 times negative 7 is 49a. I'm going to add 5 to this side, and so I get 6. So that means a equals 6 over 49. Definitely a nice, like super nice numbers, of course, but here we go. Y equals final equation. Y equals, let's see, what do we have? A. So that's going to be 6 over 49 times x minus 4 quantity squared and then minus 5. And that's our equation in vertex form. So we have a couple more problems here that you might do, but what I'm going to do is I'm going to move forward to what's going to end up being the rest of this the rest of what we're doing today, and that is a gallery walk. So you are going to be given an equation, and given that equation, you are going to work with a team to find everything about that problem that you can tell me, whether it's the discriminant, the vertex, 2 different ways, finding the x-intercepts 3 different ways, or it's finding the axis of symmetry, finding the symmetric point, and also graphing the equation. And so you are going to be working with your groups. You are going to get all of these things, whether it's increasing and decreasing as well. You're going to tell me also the domain and range. These are the equations that you're going to get. And it's going to be a virtual gallery walk on Jamboard. So if you miss class for whatever reason, this is actually what you're going to be doing. You are going to be grading each other. And so I kind of like that part. And we'll see how you guys do. And for homework, your job is to definitely finish the Jamboard if you didn't finish it in class. You also have page 186, which is odd problems, 1 to 43. So good luck. Thanks for watching. And have a great rest of your day.